Hi everyone, welcome back to Lulumath. This video is on exponent rules, and this time we are putting everything together from all the exponent rule videos that we've watched. So you need to know how to multiply monomials, divide them, and do a power to a power. And all of these videos are available at lulumath.com as well as the YouTube channel. So I'm not going to go into depth what the rules are, but I do just want to write down a quick reminder. And that reminder is, if the bases are the same, then you would just add the exponents if you multiply, subtract the exponents if you divide, and multiply the exponents if you have a power to a power. You also need to know zero exponents. And just a reminder that anything being raised to the zero power is always equal to just simply the number 1. And you also need to know order of operations. So depending on what region you live in, it's either BEDMAS or PEMDAS, where the B stands for brackets or parentheses. Now, in our first example, we're asked to simplify this whole entire expression here. I just want to remind you that if you have an entire fraction with multiple things in the numerator and multiple things in the denominator, then you want to identify the invisible brackets that we have here. And according to order of operations, the first thing we do are our brackets or our parentheses. So what this is saying is we want to simplify everything in the numerator, simplify everything in the denominator, and then simplify from there. So in my numerator, I have 5 to the power of 3 times 5 to the power of 7. And just a reminder that this is an invisible exponent of 1. So when I add my exponents of 3 plus 1, which is 4, plus another 7, which is 11, my base stays the same. So this is going to be 5 to the power of 11 because I have 11 5s being multiplied together in the numerator. Now in my denominator, I have 5 to the power of 2 times 5 to the power of 4 multiplied by 5 to the power of an invisible 1. We will add our exponents, so 2 plus 4 plus 1 is 7, so I get 5 to the power of 7. Now, when I divide, I need to subtract my exponents if my bases are the same, which they are. So here I will do 11 minus 7, and 11 minus 7 is 4. So my answer is 5 to the power of 4. Another option that you have is to just simply divide and then multiply. So if I were to do 5 to the power of 3 divided by 5 to the power of 2, I would get 5 to the power of 1. If I were to do 5 to the power of 1 divided by 5 to the power of 4, be really careful. 1 minus 4 is negative 3. And then if I were to do 5 to the power of 7 over 5 to the power of 1, I would get 5 to the power of 6. So then if I were to multiply through, remember we add our exponents, so 1 plus negative 3 is negative 2, plus 6 is positive 4. So we would still get 5 to the power of 4. I strongly suggest that you are very careful with this method. I don't recommend that you use this method because for some reason, this gives us more opportunity to make silly mistakes. And it's better to follow order of operations and see those invisible brackets in the numerator and those invisible brackets in the denominator and go from there. In this example, it's okay because it's all multiplication and division. And so it doesn't matter what order you do it in as long as you do it correctly. However, that's not always going to be the case. So on that note, I suggest that you look at this example that we have here with invisible brackets as well. So I'm going to simplify the numerator and then simplify the denominator. So when I do this, let's take a look at our coefficients first. So here I have a coefficient of 4, a coefficient of 3, and a coefficient of 5. So when I multiply 4 times 3 times 5, I end up getting 4 times 3 is 12, and then 12 times 5 is 60. So I have a coefficient of 60. Then I'll look at my a values. So I've got a to the power of 2, a to the power of an invisible 1, and that's it. That's all I see for a values. So that means that here I will have a to the power of 2 plus 1, which is 3. Then I will look at my b values. So I have b to the power of 3, b to the power of 2, and b to the power of an invisible 1. And so when I do 3 plus 2 plus 1, I get b to the power of 6. Let's do the same thing in my denominator. So here our coefficients are 2 and 6. So when I multiply 2 by 6, I end up getting 12. Then looking at my a values, I have a to the power of 3 here and nothing else like it. So I'll just copy that down. And then I also have b to the power of 2 times b to the power of 1. And when I multiply those together, I get b to the power of 3 because 2 plus 1 is 3. So now when I divide 60 by 12, I end up getting 5. A cubed divided by a cubed cancels out because when I subtract my exponents, I'll get a to the power of 0, which is 1, and 5 times 1 is just simply 5. Then I have b to the power of 6 divided by b to the power of 3, and when I divide, I should subtract my exponents. So 5b to the power of 3 is my final answer. So now in this next example, we have another set of brackets in the numerator. And even though we have brackets within brackets, there's nothing inside each smaller set of brackets here to evaluate. But we have the smaller brackets there to tell us that we are raising each monomial here inside of here to the power that's on the outside of the brackets here. And according to order of operations, we always do our brackets or our parentheses first, and then we do our exponents. And since we have powers to a power, we need to do that. So here I have 3a to the power of 8, b to the power of 3, all raised to the power of 2. So what this is saying is I have to do 3 to the power of 2, and then a to the power of 8 is raised to the power of 2. And when we have a power to a power, we always multiply our exponents. So 8 times 2 is 16. And then we have b to the power of 3 raised to the power of 2. And again, power to a power, we multiply our exponents. So 3 times 2 is 6. And then in the next part that we have here, all of this 2a to the power of 9, b to the power of 3c is being raised to the power of 5. So what this means is 2 to the power of 5, because this 2 is being raised to the power of 5. This coefficient is also being raised to the power of 5. Times, here I have to multiply my exponent of 9 by this 5. So 9 times 5 is 45. And then same thing with this b to the power of 3. So 3 times 5 is 15. And then same thing with this right here. This is c to the power of 5 because we have an invisible 1, and 1 times 5 is 5. And I'm just going to copy down what I have here. Now I'm going to simplify the numerator even more. And I'm just going to keep this 3 squared here, and I'm going to keep this 2 to the power of 5 here. And it doesn't matter what order I write it in. But I do see that I have a is my base here, and a is my base here. So when I multiply, I need to add my exponents. So I end up getting a to the power of 16 plus 45 will give me 61. I'll do the same thing for the b's. So I've got b to the power of 6 times b to the power of 15. And when I multiply, I need to add my exponents. So I would get b to the power of 21 because 6 plus 15 is 21. And then the c to the power of 5, nothing else is like it, so I'm just going to bring it down. Now in my denominator, I'm just going to copy down my coefficients, 10 times 8. And then here, same idea. I have a to the power of 1 times a to the power of 2. So together that will give me a to the power of 3 because my exponent of 1 plus 2 will give me the 3. I now have b to the power of 1 times b to the power of 3, so that will give me b to the power of 4, again because 1 plus 3 is equal to 4. And then here I have c to the power of 1 times c to the power of 1, and altogether that will give me c to the power of 2 because 1 plus 1 is 2. Now let's take a look at our coefficients that we have here. So here we have 3 squared, which is 9. Here we have 2 to the power of 5, which is 32. And down here we have 10 times 8. And then I'll just copy the rest of this down. Now for my coefficients, I could multiply 9 by 32 and I would get 288. And then 10 times 8 and I would get 80. And I can see that 288 and 80 are not evenly divisible. So I can either reduce it, and for starters, I'm going to guess that they're both divisible by 4. So when I divide 288 by 4, I get 72. When I divide 80 by 4, I get 20. And then I'm going to say, oh, I can divide it by 4 again. So 72 divided by 4 is 18, and 20 divided by 4 is 5. Or I could look and see, are there any common factors here to begin with? So I can see 32 and 8 have an 8 in common. So when I divide 32 by 8, I get 4. And then when I divide 8 by 8, I just get 1. That cancels out. And then I can also see that 10 and 4 are both divisible by 2. So I have a 5 in the denominator and then a 2 in the numerator. And then that's all that there's in common. So 9 times 2 gives me this 18 we got here. And then there's a 5 left over. So that's where we have this 5 here. Regardless of how you decide to approach it, it's clear that our coefficient is 18/5. Now let's go ahead and do our division. When we divide, we subtract our exponents. So 3 is going to be subtracted from 61 because these are both the exponents for the same base of a. So here I will get a to the power of 58 because I did 61 minus 3. Then here I will subtract these exponents. So 21 minus 4 is 17. So I will get b to the power of 17. And then here I will do 5 minus 2, which will give me 3. And this right here is my final answer. All right, try this problem on your own. Press pause, see how you do, and come back and check to see if you got it right. So the correct answer should be 50 x to the power of 19 y to the power of 21. If you got that right, awesome, you're all set with this video. If you got it wrong, no worries at all. Remember, the way you learn best is by making mistakes and understanding what your mistakes are. So follow along with the explanation, and if you have any questions, make sure to reach out. So we have invisible brackets here. So I want to evaluate the entire numerator before I even deal with the denominator. And in my numerator, I have an entire monomial being raised to a power. So I'm going to square everything inside of these brackets. So what this is telling me is this should be 4 squared times x to the power of 7 times 2 is 14, because when we have a power to a power, we always multiply our exponents. And then here, y to the power of 8 to the power of 2, 8 times 2 is 16. Again, we multiply our exponents. Then I'm going to do the same thing with the next monomial that's being raised to the power of 3. So here I'm going to do 5 to the power of 3, and then x to the power of 4 is being raised to the power of 3. So 4 times 3 is 12. And then y to the power of 2 is also being raised to the power of 3. So y to the power of 6, because we do 2 times 3. And then I will copy down my denominator. So here in my numerator, I'm going to keep my coefficients as is, just to make my life a little bit easier for now. I will deal with them in a little bit. But I can see that I have an x to the power of 14 and an x to the power of 12. So when I multiply, I need to add those exponents. So I get x to the power of 26. Looking at the y, we have got y to the power of 16 and y to the power of 6. So because it's multiplication again, we'll add our exponents, and 16 plus 6 is 22. Again, I will copy down my denominator. So now let's take a look at our coefficients. There are a couple different ways that we can look at it. So 4 squared means 4 times 4, which is 16, and 5 cubed is 5 times 5 times 5, which is 125, and that's all being divided by 40. And then I can just simply multiply across and do 16 times 125, which is 2,000, and then divide that by 40, and I would end up getting the 50 that we are looking for. Another way to look at this, however, is that we know 40 is simply 4 times 10. So if this is 4 squared, this means 4 times 4, and this 4 and this 4 can cancel each other out. And 10 is 5 times 2. So one of these 5s can cancel out with this 5. Then lastly, we have a 2 here and a 4 here, and they're both divisible by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. So now we have a 2 left over and a 5 squared left over. And 5 squared is 25, so we could just say that our answer is 50. Doesn't matter how you want to look at it, it's totally up to you. Regardless, our coefficient here is going to be 50. Then we have x to the power of 26 divided by x to the power of 7, and when we divide, we subtract our exponents. So 26 minus 7 is 19. And then here, y to the power of 22 divided by y, this is an invisible 1, will give us y to the power of 21, because this is 22 minus 1. And this will be our final answer. That's it for this video. If you have any questions, please let us know in the comments below or at lulumath.com, where you can find blank or completed notes for this video. If you found this video to be useful, please subscribe and share with others. Thank you, and we'll catch you next time. Bye!